All right, here we are on day 2 of vectors. We're going to continue this pretty simple concept. Graph each vector on the same plane. So we're going to graph vector u, and you can see that's written component form. And so vector u would be over from 0, 1, 2, 3, 1, 2, 3, 4. So here's vector u. And now it wants vector v, which is what we would call a scalar, 2u, 2 times vector u. So how much is 2 times vector u? It is quite literally just doubling the components of vectors 3, 4. So that would mean that we're going to turn this into graphing 6, 8. All right, so let's go ahead and do that. So 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, approximately 8 right here. And what you'll notice is that is going in the same exact direction as vector u, because all I've done is scaled it. Okay, so that's what's known as a scalar. All right. Now, let's talk about like why that works. Well, if we look at the component form, if we look at it sort of as a right triangle and we look at the individual components, then this is 3 and this is 4, and we know this is a 3, 4, 5 right triangle. Well, if we want to double the vector, so that would mean we want this to be 10. Well, if you remember from geometry, when you double or any scale, if you double the 5 to get 10, double the 4 to get 8, and double the 3 to get 6, it remains a right triangle. So this is simply doubling each of the components. So that's what's known as a scalar multiplication. It scales it, makes it bigger. All right. Find the component, draw a unit vector that has the same direction as u and call it w. All right. So let's think about what that would be. A unit vector, as I hope you would assume, is simply talking about a vector. Again, it tells you in the same direction, so we know we're in the same direction. But a unit vector means it has a length of 1 unit. So instead of going over 3 and up 4, we're going to go over an amount that gives the length a 1. So we're looking at something with a magnitude of 1. Or in other words, the hypotenuse of 1. So, as we just discussed, you can multiply the 3 sides of the triangle by any number as long as you keep it the same, and it'll be scaled and go in the same direction. So on the previous one, we doubled the length, but if I want to turn something that has a magnitude of 5 into something that has a magnitude of 1, then I would simply divide everything by 5. So I don't know how long 1 unit is in this because we're going on a diagonal, right? So I'm just going to estimate. I'm going to say that a length of 1 would have to be shorter than, somewhere in this range. So that would make W something like this. And of course, we should be able to come up with a component form of W. So W in component form, so vector W, would be, again, all we did was that we divided or multiplied by 1/5. So that means we're going to be at 3/5, comma, 4/5. That would be the length of vector W. Okay, and where is 3/5, 4/5? We're obviously estimating, but that would keep it within that first box here, which is where I estimated it to be. Write the formula for the component form of a unit vector in the direction of a given vector. Okay, so what the heck is that talking about? So let's say we have a given vector Let's call it vector. We've got u, v, we've got w. I'm just going to go back to u. Okay, so a different u than this one. So let's say we are given vector u. And we do not know how big it is. And now I want to do the unit vector. So we'll call that w. So in the same direction, but not the same length. We want it to be smaller. So what is it that we do? Well, what did we do to go from from the vector 3, 4 to 3/5, 4/5? That was our unit vector. We found the length of our given vector. So in that case, it was 5. And then we divided both components by the length to get it to a unit vector, to get it to 1. So how could we do that? How can we write this? I think we could write it as A divided by the magnitude of vector u, and B divided by the magnitude of vector u. Okay, so take your vector that they gave you and simply we're going to divide it by how long it is. That'll turn into a unit vector. Should make perfect sense. All right, so let's take a look at a couple definitions here. Scalar multiplication by a positive scalar, so multiplying by a positive number, changes the magnitude, the length of the vector, but not its direction. Okay, and we saw that happen twice. We scaled it by 2, we scaled it by a fifth, and we saw that it kept the same direction, just changed the length. A unit vector is a vector that has a magnitude of 1. Okay, let's keep rolling, see what's next. All right, graph each vector on the same plane. We're going to graph vector u, we're going to find the magnitude of u, and then we're going to graph the component form of the unit vector. Okay, so find the component form of a unit vector, and I guess we're going to call it v. Okay, that's what we're calling it. That has the same direction as u. All right, so first things first, let's graph vector u at 2, 7. So over 2, 1, 2, 3, 4, 7. And so we're looking at vector u right here. And that was over 2 and up 7. So that means the magnitude of u is simply the distance, right? So it's going to be the Pythagorean theorem. So that's going to be the square root of 2 squared plus 7 squared. So that's going to give me the square root of 4 plus 49, the square root of 53. Square root of 53 does not simplify, so we're going to leave it as the square root of 53. All right, so there we go. Find the length of u, that's done. And now let's find the component form of vector v, which is the unit vector of u. All right, so then that means that vector v is simply going to be our previous vector, 2, 7, but we're going to divide it by its length. So that's basically the answer. And we should know that it's not exactly our answer because we should rationalize this. And so this would be our best answer for the component form of the unit vector. And again, where is that going to be sitting? It's going to be a little bitty vector down here that has a length of about 1, right? So somewhere in here. And if we wanted to go to decimals, we could get a better approximation. but here's vector u, and then there's vector v right here. All right, so far so good. All right, so now we're going to talk about a second way that's very common when we talk about vectors, and that is about what's known as a standard unit vector, or using unit vectors. So by definition, we're going to say I, and actually let's pause for a minute. You'll notice I didn't put the vector symbol over it. These are vectors. Back in the good old days before we had computers that could duplicate and put anything we want on in a document, and we could change the fonts and everything. It was very difficult for typists to put a vector symbol in textbooks. And so another way that you'll see vectors identified is a vector might be bolded and italicized. I know I probably spelled that wrong. Okay, so the most common way now that we have computers that we can easily format things is, of course, to use that unit symbol, or the vector symbol like that. But you can also do it with a bolded, italicized letter. So vector I and vector j. So by definition, vector I is a vector. Here's 1, right? So we're going, the component form 1, 0 takes us from here to there. So in other words, it's one horizontal unit. And vector j is one vertical unit. Which means if you want to talk about something in component form, you could actually change it into its standard unit vectors. And this will make more sense when we look at an example. All right, so what does it mean to graph vector v, where vector v is equal to negative 2I plus a j? Well, when we think about I, we know that what that means is we're going to go in the horizontal direction 1 unit. Or in this case, we're multiplying it by negative 2. And so that means we're actually going to go in the negative direction 2 units. And then we're going to go up 1 unit in the vertical direction, which is j. In other words, in component form, we could have written this one simply as this. Go negative 2 in the horizontal and 1 in the vertical, right? Go 2 of these horizontal line segments, but in the negative direction, and 1 of the verticals, which would give us our vector. So negative 2 i's. So again, 1 I would be this, 2 i's would be this, 2 of those horizontal 1 unit vectors, but in the negative direction. So we're going to instead go this way, and then we're going to go up a j. So a j, again, is a vertical. So remember, when we add them together, we put the head of one on the tail of the other, or vice versa, the tail on the head. So going over 2 and up 1 puts us at that spot, which is the same as just saying negative 2 and 1. Okay, so it is just another way that vectors are communicated. It is a very common way. And so just be used to these two things. They mean the same thing. Negative 2 horizontal, 1 vertical, negative 2 horizontal, 1 vertical. All right, graph vector u, which is in component form, you'll notice. So that's at 3, 2. So 1, 2, 3, 1, 2. So here's vector u. By the way, we never finished drawing vector v. Vector v would be the connection to there. And then it asks me to write u in terms of standard unit vectors. So the 3 told us to go over 3. Well, that would be the same as saying that u is equal to 3 i's. And then we went up 2. that's adding two j's. Three i's, 1, 2, 3, two j's, add them together, and we're looking at the diagonal of that parallelogram, right? That's formed right here. So hopefully you see it's the same thing, just a different way of talking about it. All right, so that's what I have for our notes so far. I may add another add-on, but I think this is enough to get us going through our assignments and for you to get a basic understanding of vectors. All right, let me know if you have questions.